This is a problem work through for problem number 32 in lesson 3.7, calculating the apparent weight of an object. Now, in this problem, we have an 800 Newton woman that is standing on a scale in an elevator. We want to know what the scale reads when the elevator is going through these 5 different scenarios. Now, this requires a couple of important things to remember. So I'm going to write this off to the side first off. Now, the formula for apparent weight, if we remember from class, is that the force, right, Fn, the normal force, is going to be equal to mass of the object multiplied by acceleration plus the force of gravity. Now, that is our formula, but this formula requires us to remember that if we were to imagine a coordinate plane, anytime we move up, that will be positive, and anytime we move down, that will be negative. So that's important to remember when we're thinking about the elevator. Now, so let's start with our laundry list. We have a woman who weighs 800 newtons. That means that our force of gravity is 800 newtons. Now, let's break this down because we're going to eventually need the mass. So if the force of gravity equals mass times gravity, that means that mass is the weight divided by the acceleration due to gravity. So 800 newtons divided by 10 meters per second squared, which means that our mass is actually going to be 80 kilograms. That's going to be important. But let's go back to the problem. Now, if our elevator is ascending at a constant velocity of 3 meters per second, now this is important to remember. This is where that reading comprehension becomes critical. A constant velocity means that there is no acceleration. So if we look at our formula, if there's no acceleration, then this part of the formula becomes a zero. It cancels out. And the apparent weight is equal to just the force of gravity. So in this, our acceleration equals 0 meters per second squared because we're traveling with a constant velocity. There is no acceleration. So our apparent weight is equal to the mass times the acceleration plus the force of gravity, the weight. So we have 80 kilograms times 0 meters per second squared plus 800 newtons. This cancels out, and our apparent weight is 800 newtons for scenario A. In scenario B, we are now ascending at a constant acceleration of 0.8 meters per second squared. So the weight of our woman is still 800 newtons. We have an acceleration of 0.8 meters per second squared. And remember, we are ascending, so that means we are going up. So that means our acceleration is positive. Sorry, there it is. So it means that our acceleration is positive. Let's see. So our apparent weight is equal to mass times acceleration plus the force of gravity. So 80 kilograms multiplied by 0.8 meters per second squared plus 800 newtons. So 80 times 0.8 gives us 64 newtons plus 800 newtons. So our apparent weight in scenario B is 864 newtons. In scenario 3, we are now descending at a constant velocity. So if we're descending at a constant velocity, that means that our acceleration is now 0 meters per second squared. The force of gravity on the woman, the weight of the woman is still 800 newtons. And our apparent weight, mass times acceleration plus the force of gravity. Now, if we just refer back to part A, we know that when acceleration was 0, this part just cancels out. So we can go ahead and just X that out right now. We know that our apparent weight equals the force of gravity, so 800 newtons. And we're done with part C. For part D, we are now descending with a constant acceleration. So now our acceleration is going to be negative 0.8 meters per second squared, with the force of gravity still, as before, being 800 newtons. So apparent weight is mass times acceleration plus weight. So 80 kilograms plus negative 0.8 meters per second squared plus 800 newtons. Now, in this case, 80 times negative 0.8 gives us negative 64 newtons. But we're going to add that to 800 newtons, and we're actually going to get 736 newtons as our apparent weight because we are descending with an acceleration. And then in the final scenario, the cable has broken on the elevator. So that means that our elevator is now falling downward with nothing to stop it. So the apparent weight is going to be 0 newtons because in this scenario, there is no force that is preventing the fall. So she is just falling and there is no apparent weight.